Good morning, student. Myself, Satnam Singh, lecturer, electrical engineering, Government Polytechnic College, Mohali, Khuni Majra. Today, our topic is special purpose material. There are certain materials which find their application in the field of electrical and electronics engineering. In some special types, these can be joining material, protective materials, and foundation of various electrical and electronics engineering. For example, to transmit and distribute the electric power, transmission and distribution lines are to be spotted on the transmission tower and distribution pole. For making house wiring, the insulated wire are to be passed through the conduit are to be fixed on the batten with the help of clips. So, we see that in all these applications different kind of material are used. They may fall under the category of conductor, insulator or magnetic material. Since these materials serve function other than conduction, insulation and magnetization, therefore, these materials may be called material for special purpose or for special function. So far we have discussed the four type of materials, that is conductor, insulator, semiconductor and magnetic materials. These all material fall under the category of special purpose material if they are used for the special purpose. For example, in thermocouples, in fuse and in bimetals for making thermal switches, they are these all the material which are used in these special functions are called special purpose material. First is thermocouple. As the name suggests, thermocouple is the word derived from two words, that is thermo and couples. By the thermo means thermal, that is something related to temperature or heat, and couple means a joint of two. Nowadays, these are very common in the field of industry for the measurement of very high temperature. For example, in industry, furnaces are used for heating purpose. To know about the proper working of furnace, its temperature can be measured very accurately with the help of thermocouples. So, students, thermocouples is the combination of couple of two different metals. The joint of two metals are kept at different temperature. When they are kept at different temperature, then due to Seebeck effect, an EMF will induced and current will flow in these two metals without any external source of supply. Current will flow, but you can see there is no external source of supply. In order to measure the temperature, some measuring instrument is connected in the circuit. The instrument which is used is a voltmeter. This voltmeter measures the EMF induced in the circuit. Since the scale of voltmeter is calibrated in the terms of temperature, so the observer will directly take the reading of temperature. Thermocouples work on the basis of Seebeck effect. The Seebeck effect states that whenever in circuit two different metals are used to make it, the two joints made are kept at different temperature, then even without applying any external source of electricity, an EMF is induced in the circuit, and if the circuit is closed, the current will start flowing. So, for the construction of thermocouples, two different metals are used. They are joined at two different locations. Platinum and iridium are the two metals which are used for the construction of thermocouples. So, these two metals, platinum and iridium, can be named as special purpose material, because they are using not for conductions, insulations, magnetizing and semiconducting purpose. They are using for the special purpose. So, these two metals are called special purpose material. When these two materials are joined at two different locations and kept at these two joint noted with the black spot, when kept at different temperature, then without applying any external source of supply, current will start flowing in this closed circuit, and this low range voltmeter indicate the voltage across this circuit. Next is bimetals. The word bimetals is a combination of two words, that is bi and metals. The meaning of bi is two, and so the meaning of bimetal is two metals. Bimetallic strips are extensively used in various electrical devices to trip off the circuit when current in and hence temperature exceed beyond the definite value. A bimetal is made of two metallic strips of dissimilar material having different coefficient of thermal expansion. As we know that when the metals are heated, they expand. On this principle, the two metals are joined at the two ends for forming a metal strips. So this form the basis that when the metal are heated, they expand with the different temperature coefficient. A coil is wound on the bimetallic strip through which current flows. One end of bimetallic strip is fixed and other end is free. When the current flowing through the coil wound on the bimetallic strip exceeds the normal value, the bimetallic strip causes tripping of the circuit. When the bimetallic strips cool down, it bends in the other direction and returns to its original position, thus closing the circuit. Alloy of iron and nickel having low temperature coefficient of expansion form the element of strip. So bimetallic strips consist of two metal 1 and metal 2. Generally, alloy of iron and nickel used for the construction of bimetals. One end of the bimetals are fixed and other end of bimetal is movable. So when you can see clearly in this figure, when current flow from these bimetals, this is made of two metals, one is indicated by red lines and one is indicated by blue line. When current exceeds its normal value, then the due to different temperature coefficient of expansion, the bimetal will bend and circuit will disconnect. And when this bimetal cool downs, then again it regain its original position and circuit will close. So this form the bimetals. And alloy of iron and nickels are used for the construction of the bimetals. These materials are called special purpose material because they are used not for conduction, not for insulation, and they are using for special purpose, that is they are using for protection of the circuit. So these two materials are known as special purpose material. Next is soldering material. Soldering is a technique of making joint between two or more material in electric circuit or electronic circuit. When the connection are to be made with maximum strength and minimum possible contact resistance, soldering is done. In this process, the base metal do not melt, they are joined by melting another material. This material heated with the help of soldering iron. The most commonly used soldering material is an alloy of tin and lead. This alloy contains 63% tin and 37% lead. Its melting point is 183 degrees Celsius. This soldering material is used to make joint almost in all electronic circuits such as TV, telephone, radio, VCR, etc. So to make the joint in electronic circuit, we use the soldering. The characteristics of soldering is it should have maximum strength and minimum possible contact resistance. During this soldering process, medium is used to increase flow property of molten solder. Such a medium is called flux. It is generally observed that layer of oxide is formed on the surface of the metal which is to be soldered. In order to make the joint properly strong, it is must that the oxide layer must be removed from the surface of base metal. In order to remove the oxide layer from the base metal, flux is used. The most commonly used material is zinc chloride. The flux must possess the following property. First one is it should be capable to dissolve any oxide on the metal surface or on the solder. Second is residue should be removable after completion of solder. Third is it should be provide a liquid cover over the material and exclude air up to the soldering temperature. Iron soldering is most common method of soldering nowadays. In this method, soldering is done with the help of soldering iron. Soldering iron consists of insulated handle connected via metal shank to bit. The face of bit makes contact with the component parts of the joint and solder heats them up while making joints. The surface to be soldered are thoroughly cleaned, then treated with the flux unless flux cord wire is used. The solder is brought near to the surface and then melted with the help of soldering iron. Melted solder should completely penetrate and fill the gap of joint. The joint are then allowed to cool down. So the soldering is done with the help of this soldering iron. The joint, where the joint is to be made, is done with the help of this soldering iron tip, and flux is used to remove for the proper joint of the two metals. Next is fuse material. Electric fuse is a device used to prevent electric circuit or electric wiring from heavy overload current and short circuit current. It consists of piece of thin wire made of metals of low melting point. It may be of lead or tin, placed in series with the circuit of load to be protected. These are the most sensitive part of electrical or electronic circuit. If the current exceeds then the normal value due to overloading or due to short circuiting fault, the fuse wire melts within a specified time, thus breaking the circuit and thereby protecting the equipment or other component connected in the circuit. So you can say fuse is the weakest point of the circuit which breaks when fault occur. Overload current and short circuit fault occur. A fuse should always be put in the face of wire and not in the neutral wire, because in the case of melting of the fuse, the appliance or equipment will remain connected with the face and every possibility of shock will exist. So student, always fuse are always connected in the phase wire, not in the neutral wire, because if we connect the fuse in the neutral instead of in the phase, then the high current will pass through the component and it can damage the device or component. Fuse material. So these are the three types of fuse which are used. First one is KitKat types or revival fuse unit. Second is cartridge type fuse unit. Third is HRC fuse unit, that is high rupturing capacity fuse unit. First is KitKat type fuse unit. This is the most commonly used fuse unit in house wiring and power wiring up to 440 volt. This is made of porcelain in two parts. One is the base unit and other is a fuse carrier. The fuse carrier can be removed from the base unit. The thin fuse wire is fixed in the removable part and held between the two screws. The fuse wire inserted from one side to the base unit and connected to the metal caps. The outgoing connection is taken from the other terminal in the porcelain base. The two terminals inside the base are connected by the fuse wire which is held in the fuse carrier. In case of fault or overcurrent, the fuse wire metals and is replaced by a new fuse wire. So fuse consists of two parts. First is fuse carrier and second one is base. Uh, the, the fuse wire is uh, held in the fuse carrier, and base consists of two terminals which are completed with the help of these fuse carrier. You can see clearly in this figure, this is the base and this is the fuse carrier. The base consists of two terminals which are connected through this fuse wire. This fuse carrier will hold in these metal clips. When in the normal condition, the current will pass through this fuse wire. When fault occur, then the current will rise abruptly and the fuse wire will melt and circuit will break up, and so this will prevent the any damage to the equipment which are connected in the circuit. Next is cartridge type fuse unit. It performs the same function as the previous fuse unit, but the construction of cartridge type fuse unit is different, and it is designed for high voltage and high current. This is a totally enclosed type fuse unit. The container which carries the fuse wire is also filled with powder. The container is sealed on both the ends with metallic caps known as cartridge. Since it is totally enclosed type of fuse unit, therefore it is not possible to rewire it. In case the fuse blows out, the whole unit will have to be replaced. Such units are available for voltage up to 660 volt and current rating up to 800 amperes. The powder filled in the container also serves as a good insulator. So cartridge type fuse units are not a rewirable fuse. That means the fuse wire cannot be rewired. Once it breaks, then the whole fuse unit has to be replaced, and this fuse is filled with the powder which act as an insulator and extinguishes the arc when this fuse melt. This fuse is used for 660 volt and current rating 800 ampere, and this fuse wire is enclosed in two metal caps known as cartridge. The next is high rupturing capacity fuse unit. With the heavy generating capacity of the modern power stations, if some fault occur, very heavy current will pass. Therefore, the fuse required for clearing the fault must be capable to withstand the heavy stress in the process. In such condition, rewirable fuses are not useful, so HRC fuses are therefore used for such duties, and these are specially designed for rapid operation. These fuses are also designed to dissipate the heat generated by the arc at the time of blowing out HRC fuse. HRC cartridge fuse consist of heat resisting ceramic tubes of heavy contact of each end to which is welded the fusible element. The space around the fuse element is filled with the incombustible powder which extinguishes the arc which is produced at the time of blowing out of fuse to avoid the possibility of any kind of flash over occurs across the adjacent live lines. The rating of HRC fuse is much more accurate, and as already mentioned, they are particularly suited for breaking much heavier current safely. So high rupturing capacity fuse are used where heavy current is to be break safely. Uh, it capable of withstand the heavy stress when fuse blow out, and when the fuse blow out, the powder fill in the HRC fuse extinguishes the arc. Next is material used in making DC machine. Main part of DC machines are: first one is field magnet frames or yoke, second is pole core and pole shoes, third one is pole coil or field coil, fourth armature core, fifth one is armature winding, sixth commutator, next is brushes, brush holder, bearing and shaft. So, first part of DC machine is field magnet frame or yoke. The yoke or outer frame is the covering provided to DC generator or machine, and it serves the following purpose. First is it provides a mechanical support for the poles. It acts as a protective cover against mechanical damage, and third is it provides passage for the magnetic flux produced by the poles. So, this outer covering is called yoke or magnetic frame. It perform three functions. First is it hold the poles, second it provide protective cover against mechanical damage, and third it provide passages for magnetic flux which is produced by the poles. It provide the easy path for the magnetic flux which is produced by this pole core and pole shoes. Material used: the material used for the yoke is cast steel or rolled steel. Since the function of outer frame is to provide mechanical protection and to give support to the pole cores, therefore they should be mechanically strong. The flux set up by the field coil also links the outer frame, so the material used for the construction of outer frame should have high value of permeability. Cast steel or rolled steel is usually used. The material also offers less reluctance to the magnetic flux. So, cast steel or rolled steel is used for yoke because they are mechanically strong and provide a easy path to the flux. Next is pole core and pole shoes. The pole core and pole shoes are made of lamination of silicon steel having a thin coating of black varnishes or alkyl resin varnishes. These laminations are assembled together with rivets. Pole cores are laminated to reduce the eddy current losses because eddy current losses are directly proportional to the square of thickness. The second advantage of using silicon steel as a pole core material is that it has high value of permeability, low value of residual magnetism, high value of saturating flux and less hysteresis losses. As this pole cores and pole shoes form the magnetic circuit, so the material used for the pole core and pole shoes should be such that it prevent the or it reduces the magnetic losses such as eddy current losses and hysteresis losses. Hysteresis losses can be reduced by using the material that is silicon steel, and eddy current losses can be reduced by constructing the pole core and pole shoes with the number of stamping. So, we use the number of stamping to form the pole core and pole shoes rather than using the one complete material just set for constructing the pole core and pole shoes. We use a number of laminations. Next is armature. The armature core is a cylindrical in shape. It is a rotating part of the machine. The armature winding or armature conductor are placed in armature slots provided on the outer periphery of the machine during the working of the machine, so it has to face the continuous reversal of flux which result in hysteresis loss. Secondly, the metallic core also cut the main magnetic field, hence and result eddy current are also induced which flows through the core and produce eddy current losses. The use of high grade silicon steel is made in which hysteresis losses is very low. To reduce the eddy current losses, the armature core is made of thin lamination which are insulated from each other by a thin coating of varnishes. Again, the armature again cut the magnetic flux, so EMF induced in this armature uh, also due to magnetic flux cutting. This is made of magnetic material, so the losses that is magnetic losses, that is hysteresis and eddy current losses, should be minimized. To minimize eddy current losses and hysteresis losses, we use materials silicon steel, and we make this armature from the number of stamping. Next is armature winding. Armature coil are usually former wound. The conductor are placed in the armature slot which are lined with tough insulating materials. The material selected for armature winding is copper, which have low value of resistivity, hence the area of cross section of the winding wire is less. This reduces the weight of armature winding. The weight of armature should be less because of the reason that it is a rotating part. So, for the construction of armature winding, we use copper because the resistivity of copper is low. When resistivity of copper is low, so area of cross section for the winding is less, which reduce the weight. As the armature winding is a part of rotating part of the machine, so the weight of armature winding should be less, so we use the copper wire for the construction of armature winding. Next is commutator. The commutator is a cylindrical in structure and is built up of wedge shaped hard drawn copper segment. These segments are insulated from each other by a thin sheet of high quality mica. Commutator is mounted on the shaft near armature. The connection of the armature are made with the commutator by soldering. Brushes. The function of brushes is to collect the current from the revolving commutator and to supply the external load circuit. The brushes are housed in the stationary brush holder. Since the brushes are placed on the revolving commutator surface and they remain in contact with the commutator, so there is a continuous rubbing with the commutators. So this rubbing causes friction losses. Due to this friction, the brushes get heated. So due to this reason, carbon in the form of graphite is used. Since the carbon is semiconducting material and it has negative temperature coefficient, that is, its resistance decreases with the increase in temperature. Other quality of graphite is that it is soft material and also self lubricating, and carbon is most suitable material for breaking brushes. As you can see in this diagram, this is a brush holder and brush is held in the brush holder. This brush holder will make connection with the rotating part. It withdraw or it deliver the current to the rotor. When rotating part rotate, this brush rub with the rotating part, so temperature of this brush will increase. So the material chosen for the brush should be such that with the increase in temperature resistance must decrease. So, we use the carbon in the form of graphite for the brush material for